In this video, we're going to talk about determining the number of valence electrons, its relationship to electron configuration, and why the heck this is important. Okay, so I've given you an example of chlorine again. So we're back to the electron configuration for chlorine, and we've given you the noble gas notation. Now, if I wanted to draw, let's go back to a really cheesy representation of chlorine. So there's my nucleus and my N=1 principal shell. These are not, I'm not showing you the orbitals. I'm just saying, hey, about here are my electrons. And for my N=2, I have my S and my P orbitals. I'm not drawing those out, but they're going to be farther away from the nucleus. And then I have my N=3. My electrons are even farther away with my sp and d orbitals. Now let's make a connection between here. My 1s2, my electrons will be somewhere around here, right? And then my 2s, they're getting a little bit farther away, but I'm going to continue coloring these green. The electrons are somewhere in here in orbitals. We're not showing them, but we know we have all of these electrons, these 10 electrons on the inside, and our 3 shell, or our principal third shell, I have 7 electrons. Just the probability of me finding them is farther away. So these electrons on the inside are called core electrons. And I picture this being like an apple in the core. If I took a bite, I'm not going to hit the core, right? If I took a bite, I would be at my outermost electrons. So these core electrons are we call them the innermost electrons, but really, so innermost electrons, that's what we call them. But really, they're just not the valence electrons. The valence electrons are the electrons in the outermost shell. In the outermost shell. That is one big representation. So I have the outermost shell, or I'd say highest principal shell. Highest principal shell, highest N. My electrons that are farthest away from the nucleus. And you remember they're farther away from the nucleus. They're higher in energy because they're farther away. And what else do we need to say? So valence electrons, they're the outermost electrons in the highest principal shell. The core electrons are in the innermost. And the reason we care about this is that it's going to dictate how atoms behave, how they react, how they form bonds. Do they lose electrons? Do they gain electrons? All of those things. So we're finally getting to the stuff that's really, really, really relevant, bonding, but we had to have the foundations before so we could talk about this. Okay, so how many valence electrons are in lithium? So this is really nice. We already have only the valence electrons drawn out in each of these boxes with your element. So you just look and you say, okay, lithium has in its outermost principal shell, it has 1. Beryllium has 2. Boron has 2, has 2 plus 1, that would be 3. Carbon has 2 plus 2, 4. Nitrogen has 2 plus 3, 5. You get the point, but do you also notice a trend? So 2 plus 4 is 6, 2 plus 5 would give me 7, and 2 plus 6 gives me 8. The trend is that I actually don't have to write out the whole electron configuration to determine how many valence electrons there are. So that is really nice. Instead of writing out the whole electron configuration, I can actually just write out, I get my periodic table, and I say 1, 2, 3, 4, 5, 6, 7, 8. That tells me the number of valence electrons. I don't want you to forget where it comes from, though. Where the number of valence electron comes from, it comes from the electrons being the outermost shell and you can see them in your electron configuration. Okay, so let me ask you, how many valence electrons are in phosphorus? Like, well, I don't know, Michelle, yet. Let me write this in. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Phosphorus has 5. Magnesium has 2. What about sulfur? 6. Okay, so determining the number of valence electrons is actually really easy. You just have to remember 1, 2, 3, 4, 5, 6, 7, 8. Write it up on your periodic table. You get your periodic table. You're doing electron configurations. You write your 1s, 2s, 3s, 2p, 3p, your valence electrons across the top, and you are ready to go. This is just one more visual for showing where the valence electrons are. The valence electrons are the ones that are in my outermost shell. So here we know the electron's moving, but it's showing you I have an electron in my outermost shell, in our outermost valence shell. Those are my valence. That is a valence electron. Valence electron. And these two would be called what? What would you call those two electrons? Hopefully you're saying my core electrons. Those are my core electrons. If I asked you how many electrons are in the in your core, how many core electrons do you have? You would say, okay, I have 2 electrons. And then in my second principal shell, 1, 2, 3, 4, 5, 6, I have 7 valence electrons. Those are the electrons that are on the outside, and they're going to be the action makers. What are valence electrons? They are the electrons in the highest principal shell. Highest principal shell, principal AL. Sometimes I misspell it. Highest principal shell. And sometimes we say outermost electrons. They are really important because they tell us what ion is it going to form. They help us predict. So I'm going to say they help us predict what ions it will form. Ions will form. And they help us predict the number of bonds atoms are going to make. Bonds made. Give an example. Okay, I don't feel like drawing, so I'm just going to draw. I'm going to write out the electron configuration for carbon, my favorite element. 1s2. Do you have a favorite element? If you don't, you should. So carbon has 6 electrons. I drew out the electron configuration for it. My outermost principal shell is my 2, right? So my 2 is my outermost principal shell. And I want to show that I have my valence electrons. So give an example of valence electrons. These are my valence electrons in the outermost shell. So boop, boop. These are my valence electrons. And maybe if I'm really showing off, I'd say core electrons. Those 2 electrons are my core electrons in my 1s orbital. Give a non-example. Okay, I actually just gave a non-example to me, but the non-example is going to be if I highlighted, oops. So let's highlight, I'm going to highlight my core electrons. That is a non-example. Those are core electrons. Really, maybe I wouldn't want to even highlight those, the core electrons. I really want to show you I know what I'm doing. Anyway, it's getting super busy, but you get the picture. Okay. So I want you to come up with your own example of these, and I'd really like if you give the definitions in your own words.